Hello, this is Vadim Dyadechko. I'm happy to talk to Wolfgang Bangerth from the Colorado State University. Hi, Wolfgang.
Hey, Vadim. Good to talk to you.
Likewise. I know you have a long history of scientific software development. Please tell us about yourself, your projects, and why you're interested in developer productivity.
Yeah, sure. So I sort of fell into this, like a lot of us, that I started to develop open source software when I was a college student, and then eventually wrote or started my own project. It's a finite element library called Dyadechko. And back in 2000, when everybody was putting things online, then we just created a website and decided to make that online too. And it's been quite an interesting project since then. So it was originally me and two colleagues in Heidelberg, Germany, who developed this software, and now it's I think over the years maybe 250 people who have contributed to this, and we're about a dozen principal developers who spend a substantial fraction of our days doing that. And so suddenly, of course, not suddenly, over these 20 years, then I ended up with a project that is actually quite large, where a lot of people contribute and a lot of people actually use it. So we have a few hundred users, maybe a couple thousand users. We know of at least 1,500 publications that use Dyadechko. And so you end up with something that has a much larger focus than just what you do yourself, and you care for a whole community. And so that's where my interest in productivity comes in, and how to document things, how to teach users, but also how to teach future developers. That's where my background is.
Thank you, Wolfgang. So the productivity metrics are surely both individual and project dependent. What metrics and indicators you look at when you're evaluating the productivity of yourself and of your team?
Oh dear, you're asking me the question about metrics that NSF always wants us to answer, and I never really have a particularly good answer to this. And I think part of that is also that when you deal with open source, people from around the world contribute to software. I don't pay them, right? I have no real right to actually measure how productive they are, because I have no way of telling them that they are too productive, that they are not productive enough, or how highly productive they are. So for me, I think the principal metric that I care about when you build a collaboration of people from around the world who volunteer their time, it's enthusiasm, right? It's, how much are you willing to contribute to the project? And that can come in many different ways, right? You might be able to write great code and functionality, but there are other people who deal with questions on the mailing list. I myself, for example, don't spend all that much time programming anymore. I spend a lot of time reviewing code, though. So I think for me, maybe the roundabout answer to your question is that there's not really particularly good metrics when you have such diverse projects. The question is more as a project, well, how can you cover all of the bases that you need to cover? Continued development, bug fixes, tending to a user community, writing documentation. And I think if everybody finds a niche that fits them in this sort of ecosystem, that's sort of the best possible outcome for me.
Do you guys have any specific deadlines in your work, or it's pretty much just flowing naturally as time permits and as resources permit?
So I think individuals have deadlines. So as a project, so I am one of the principal developer and maybe the oldest one who's still around, but the only real central deadline that we have is that once a year in May, we want to bring out a release. And so that's a deadline that we try to keep. But then many of us have individual projects that are funded by the National Science Foundation or by funding agencies in Italy or in Germany or wherever they are. And they often come, of course, with deliverables that they have to produce. Oftentimes, these projects have deadlines. And so in my own work that's funded by the NSF. There are deliverables that have to come at certain dates, but that is not sort of at the project scale, right? That if there is somebody in Germany who promised in their project to develop, I don't know, we've always used quadrilaterals and hexahedra, and so somebody comes along and wants to do tetrahedra and triangle, for example, then they might have their own deadline. And as a project, that matters to us, of course, because they will want to have this functionality in the library, and we need to review it in time. But we're not responsible for the actual development. So, I mean, we're good colleagues, and we listen to each other, we help each other, and at the end, I think as a collaborative, we're better off by respecting other people's deadlines. But at least as a project leader, I cannot impose deadlines other than the annual release that we have.
I'm curious, how big is the core of your team? And surely it's hard to organize all these people remotely without meeting with them every day. What major challenges and factors that make the life of scientific software development in your project harder than it should be?
Yeah, so it's a team of approximately a dozen principal developers who I would say all spend maybe a third or one half of their time on this. So on developing functionality and reviewing patches by others. One of the things that I found is everything becomes easier in these very distributed collaborations if you know each other reasonably well. And so over the last few years, we've always tried to set aside a week where we meet somewhere, where we lock ourselves up in a particular place and develop software together and talk. And I would say that we're actually reasonably good friends all. It's an interesting collaboration. But it is true that it's difficult to organize these things because we're distributed across the world. We're in many different time zones. And so for us, the medium that we found for this group that works reasonably well is a GitHub. So a lot of the development that we do is that one person develops something, somebody else maybe fixes something, or maybe they collaborate, but it all goes through GitHub and GitHub notification. Every patch is reviewed, and so that also can work in different time zones. We don't actually have to talk about this. We can just leave comments. And so GitHub has really been a very useful tool. Before that, it was a lot of emails, and these online collaborative workspaces are much better for this. We use Slack. Not a huge fan of Slack, so we use it where necessary, but we're not adamant users of it.
I guess you started answering my next question in a way. I was wondering about some technical means and opportunities that you guys find useful in your work. Yeah,
so GitHub really is a game changer. We used Subversion for a long time before that, but Subversion doesn't allow patch review. And so one of the things that we're actually really good at is I think we produce pretty high quality code. And GitHub makes that possible because every patch is 100% reviewed, and that's true for everybody. So I might be the oldest one in this project, the person who started it all, but I get no slack in this regard. My patches also have to be reviewed, and my colleagues are no less harsh with me than with anybody else. And I think that really is what makes good quality software happen, that you can point out when the documentation is not adequate, or maybe that something could be generalized, or that something is actively wrong. So we end up with something that actually works. I think GitHub is really a fantastic tool for this.
I see. Not every problem has a technical solution. And I was wondering if you see any cultural or organizational approaches that, in your opinion, can streamline the scientific software development.
Yeah, so for us, it's really getting to know each other well. And so maybe I'll expand on the answer a little bit. I've been looking at other projects for a very long time and seeing how they organize their work and what works for them and what doesn't. And what I often find is that the key factor, whether a software project actually works well or does not, is not what technical means they use, but how well do people get along with each other. And there are projects, and I could name them, but I'm not going to, where there are sort of, the proverbial alpha male who needs to have control, maybe not over the whole thing, but over that part of the project that is theirs, right? They wrote it, nobody else can touch it. And for whatever reason, I don't know, maybe we all ended up with, beta people in our project, but we get along, we like each other. And many of us roam over the entire software library, fix things all over the place. And so we're not territorial. And I'm not sure how to put that into words. There's no technical means that make that happen. I think it is really just finding a group of people that really work well together. And getting to know each other is something that's quite useful. I mean, many of us have known each other for a long time, but we mostly met, let's say there's somebody who starts to use the software, they come to a user workshop, we sit together and we chat and we encourage each other or we encourage a newcomer to contribute their code to the software library. And all of, other than me, all of the other principal developers eventually came into this project through this route and felt like there's a place for them, right? There's a place where they can contribute something, where they're not feeling like they're stepping on somebody else's toe. And so to me, the thing that really makes things work is to know each other, to meet in person, and maybe in these times meet through Zoom calls. So we have occasional Zoom calls in our project where we're not necessarily talking about technical stuff, but where it's, we might have a beer as well, where our Italian colleagues will have a glass of wine.
That's wonderful. I totally agree on your comment about knowing each other and having the right synergy in the project. This is the most important thing to have in order to enjoy, so that everybody can contribute and be happy, be part of this project. And to wrap up our conversation, I was wondering if you have some other final remarks on productivity and sustainability of scientific software development.
Yeah, so maybe two. So one is patch review makes code so much better. I mean, I have been programming since 1987, and I've written in C++ since I think 1991, and you'd think that I'm good at it. And I probably am, but even though I'm a good programmer, if one of my colleagues points out that something could be done in a different or better way, it's a learning experience for me, right? And I think at the end of the day, if we're honest with ourselves, then letting other people critique our work actually makes it better. And so, I mean, I learned a lot of different things about software design, software development from other people who critique my work. And I think at the end of the day, we ended up with a better software than we could have if every one of us had sort of their own fiefdom, where I deal with linear algebra, you deal with the mesh, somebody else deals with matrix-free stuff. We don't work that way, and I think it's for the better because we help each other become better software developers. And then the other thing, so we've I don't know, 5 or 6 years ago, started something that we call hackathons, where we put between 10 and 20 people, and maybe 25, into a house for 10 days. And we just spent the entire day programming. There's a day in the middle where we relax a little bit. But these things are fantastic. I mean, they're super productive. They also build community. And if I could suggest that anything be replicated from my experience in other software projects, that would be it.
Thank you so much, Wolfgang. It was very nice talking to you.
Pleasure talking to you too.